Alright, we're going to start 2.3, the properties of functions, and we're going to go over the symmetry. So if you are symmetric about the y-axis, then the function is even, and if you're symmetric over the origin, then you have an odd function. So this first one, we can see that it's symmetric over the y-axis, so this is an even function. This second one has no symmetry at all, so this is neither. And our last one is symmetric about the origin, so this is an odd function. Now we're going to determine algebraically. So for our first one, we're going to first check if it's even, and we're going to plug in negative x for all the x values. So negative x squared minus 5 is x squared minus 5. So it is even. And then let's look at b. We're going to test if it's even. So negative x cubed minus 1. That's negative x cubed minus 1. So that's not even. Then I'm going to check if it's odd. And I'm going to do negative f of x, which equals negative y. We are plugging in for the negative y, so negative y equals x cubed minus 1. So I'm going to divide everything by negative 1 and get y equals negative x cubed plus 1. And that does not equal negative f of x. Or negative f of x does not equal f of negative x. So determine if it's odd. Negative f of x has to equal f of negative x. So basically when you're plugging in that negative for x, when you're testing for even, that's what it has to equal to be odd. And that this does not equal that, so it's neither. And then lastly, let's start with even. So 5 negative x cubed minus negative x. That's negative 5x cubed plus x. That does not equal the original equation, so it's not even. Now to test for odd, we're going to start with that negative. So negative y equals negative 5x cubed minus x. Divide everything by negative 1 and get y equals 5x cubed plug it into the original equation, so there was no negative to start with. I knew I was missing something. That negative, I erased it. We didn't start with that in the original. So it's negative 5x cubed minus x, or plus x. Okay. Plus x, and this equals that, so it is an odd function. Okay, so determine whether a function is increasing, decreasing, or constant. You're going to look to the left, from the left to the right of the graph. So determine where the function is increasing, decreasing, or constant. So let's just start with decreasing. So when we go down, right there's decreasing, and right here is decreasing. So decreasing is from the points negative 6, and you're using the x value, to negative 4, and then from 3 to 6. And then let's do increasing, and that's right here is the only time this graph is increasing. So that's from negative 4 to 0. And then constant, where your graph is flat, is from 0, the x value of 0, to the x value of 3. So 0, 3. Okay. Next, we're going to talk about the local max and the local min. So using a graphing utility, we're going to graph this function and approximate where f has a local max or min. So I'm going to go to our graph and plug this in. So utility, and I'm going to plug in our function, cancel, which was 6x cubed minus 12x plus 5. Okay, plot. And we know this is a cubic, so I'm just going to scroll in. So the local max is going to be right near where my spider is. And I'm going to press menu, function, and then you can press extremum. And so that local max is at negative 0.82. Then I'm going to click near the other swoop and do menu, function, extremum. And that's our local min. And so our local min's at x equals 0.82. Okay, so local max at x equals negative 0.82, and local min at x equals 0.82. Determine where f is increasing and where it is decreasing. So they wanted to cut off our graph, as we can see, from negative 2 to 2. And we can do a little sketch of our graph then, which would look something like this. So it was from where it's increasing would be here and here, and we already know those points because that's our local max and our local min. And so from 2, because that's where we cut off the graph, negative 2 to negative 0.82, it's increasing, as well as from 0.82 to 2. That's where it's increasing. And then it's decreasing at the blue, which is from negative 0.82 to 0.82. And that is when it's decreasing. Okay. Lastly, we're going to go over the average rate of change. So we have a formula here for how to find the average rate of change. So you just have to plug in. So from 1 to 2. So from A to B. So when we write this, we would say f of 3 minus f of 1 over 3 minus 1. So let's find f of 3. You just plug in 3 into the x in our equation. 3 squared is 9, and 9 times 3 is 27. And then f of 1. 1 squared is 1, and 1 times 3 is 3. So I'm going to plug in those values. So 27 minus 3 over 3 minus 1. 27 minus 3 is 24, and 24 divided by 2 is 12. Alright, and let's try the next from A to B. So now I just have to figure out what f of 5 is, because I already found f of 1. So 5 squared is 25, and 25 times 3 is 75. So 75 minus 3 over 5 minus 1. and that is 72 divided by 4, which equals 18. A to B. So let's figure out f of 7. 3 times 7 squared. 7 squared is 49. And 49 times 3 is 147. So 147 minus 3 over 7 minus 1. 147 minus 3 is 144 over 6. And that equals 24. Alright, that finishes this lesson. Let me know if you have any questions.